Assalamualaikum warahmatullahi taala wabarakatuh. Alhamdulillah, terima kasih kepada anda yang masih lagi bersama dengan saya pagi ini dan harap semua dapat hadir awal pada pagi ini on time. Jadi saya bagi masa dalam masa untuk anda merekodkan kehadiran pagi ini untuk topik yang pertama yang berkaitan dengan fluid mekanik. Jadi saya sertakan rekod kehadiran untuk anda uh, agar dapat pastikan rekod kehadiran ini diambil. Jadi seperti mana yang sedia maklum, nama saya Muhammad Abdul Hakim bin Muhammad, Jabatan Kejuruteraan Mekanikal, Pusat Pengajian Diploma. So bilik saya di Paras 2 Blok A1 Nombor bilik 143. Okey. Ada email dan saya punya website lah. Baik. Kita lihat kepada topik yang pertama iaitu Introduction to Fluid Mechanics. So what is fluid mechanics? Okay, the branch of science that studies the behavior of fluids, either they are in motion or at rest. So it's divided into three sub-disciplines. Number one is fluid statics, number two is fluid dynamics, and number three is fluid kinematics. What is the difference between this item? So fluid statics is a study of fluid at rest. Example like calculating the hydrostatics force on water gate and get dam. And also fluid at rest is include fluid in one tank, fluid in reservoir, lake, sea, and etc. Next, fluid dynamics is about the deal with fluid flow. The study of fluids in motions, calculating lift and drag forces on a craft, determining the mass flow rate of petroleum throughout pipelines, blood, bloods, flow analysis, and predicting weather patterns. So this is the picture about the hydrostatic force on the dam and the determination of Beyond's force on of the content. Okay. So the third one is fluid kinematics. Fluid kinematics is the study on how fluid flow and how to describe fluid motion without considering the effect of external pressure or force that cause the motion. So its study on the fluid flow includes streamlines, strict lines, path line, timelines, concept of vorticity, and wakes. So this is picture about the flow study, field, flow pattern throughout visualization technique. So the application of fluid mechanics is about the number one is the more and many engineering system, especially for the mechanical engineering. So we include the design and analysis of pumps, turbine, aircraft, boats, submarines, rocket, jet engine, wind turbines, steam power plant, refrigeration system, hydraulic system, engine and radiator system, lubrication, the transportation of fluid like water, crude oil, and natural gas, etc. And secondly is the civil engineering. Civil engineering is include design of buildings, bridge, dams, transportation of river, sediments, pollution, study of air and water, design of piping system, fluid control system, and etc. So this is the picture about the on November 1940, the original Tacoma Narrows Bridge roadway twisted and vibrated violently on the delay of the collapse. So you can see in the author, okay, especially in the author, this one, you can see in the learning material. So this is the introduction of, you can see this one, this is the, upload the video about the Tacoma Bridge. Okay, we go to the next slide. So another application of fluid mechanics is the biomechanics or biomedical. So study on the blood flow throughout the arteries, organ rupture under hypertensions, condition flow of several fluids, designing the artificial heart breathing machine and dialysis system. And also meteorology and ocean engineering is about the movement of air current and water current and the water and the weather patterns. And also discipline of the chemical engineering is about the design of chemical processing equipment. And lastly, electrical engineering. We study in the cooling of electronic components, power generation, especially on hydroelectric power plants, steam power plant, gas turbine, and wind turbine, and so on. So this is the picture among the application of fluid mechanics. You can see very types of application of fluid mechanics. So what is the properties? Fluid properties is the substance that can be flow or deform continuously under applied shear. A solid is hard and not easily deformed, whereas a fluid is soft and is easily deformed. So among three types of water, solids, liquids, and gases, only liquid and gases are considered as a fluids. But fluids is about the water, oil, lubricant, and milk. Not fluid is about the solid. So, for example, of the solid is the steel, diamonds, rubber bands, and paper. So this is a comparison between the liquids and gases. You can see this is more on because of their molecule spacings. Liquid normally have higher densities than gases. What is the difference between the compressible and incompressible fluid? A flow is classified as being compressible or incompressible depending on the level of variation of density during flow. A fluid is said to be incompressible if the density of fluids remain really constant throughout. The density of liquids are essentially constant, that is, thus the flow of liquid is definitely incompressible. Therefore, liquid are usually referred to as incompressible substance, while gases, on the other hand, are highly compressible. This is the diagram about the density versus temperature of the water, function of the temperature. You can see 1000 kilogram per meter cube with the temperature of 40 degrees Celsius, 4 degrees Celsius. So what is the difference between the Newtonian fluid and non-Newtonian fluid? Newtonian fluid is about any fluid that behave in accordance with the Newton's law of viscosity are called as a Newtonian fluid. For example, like water, oil, gasoline, benzene, kerosene, alcohol, and glycerin are classified as a Newtonian fluid. While the non-Newtonian fluid is about the fluids of which shearing stress is not linearly related to the rate of shearing strain, or in other words, we call the fluid which do not obey Newton's law of viscosity, are designed as the non-Newtonian fluid. Generally, non-Newtonian fluids are complex mixture, fluids, so it's paste, gel, polymer, solution, and etc. Although there are variety of the types of non-Newtonian fluids, the simplest and most common are the fluids with times independence behavior as shown in the following figure. So this is a non-Newtonian fluids. You can see the types of the Bingham plastic, the pseudoplastic, Newtonians, and also the dilatant. So what is the importance of knowing the fluid properties? The important is the different fluid can be grossly different characteristic. For example, gases are light and compressible, whereas liquids are heavy by comparison and relatively incompressible. A fluid flow slowly from the container, but water flow rapidly when pulled from the same container. To quantify these differences, certain fluid properties are used. So in this chapter, we look into several properties that play an important role with the fluid mechanics analysis. So we study on the density. Density is the type of the parameter. It's very important of the substance in the quantify the of metal contents in the unit volume of the substance. It can be expressed in the three different ways. One is the mass density. Number two is specific rates gamma, specific, and lastly specific gravity SG. So the mass density, also referred as only density, is described as the heaviness of the fluids, designed as by the Greek symbol rho. Rho is equal mass divided by volume. So the unit SI for the density is kilogram per meter cube. Okay, so the value of density for some common liquids, for example, like atmospheric pressure 1.013 bar, and temperature at 4 degrees Celsius. So this is the constant value, especially for the water H2O 1000 kilogram per meter cube, air 1.23 kilogram per meter cube, and lastly is mercury 13546 kilogram per meter cube. So there are three times sample of water which obtained from the different sources. So sample from Nile River, sample from Amazon River, and sample from Mekong River. Question is, do all the same has the same density? Okay, the answer is one still constant 1000 kilogram per meter cube. So how about the specific weight? So designed by the Greek symbol gamma, specific weight is defined as the weight of a substance per unit volume and can be expressed as gamma is equal to rho g. Rho is the density, g is the gravitational acceleration, 9.81 meter per second square, which is constant. The SI unit for the specific weight is a Newton per meter cube. So the sum common value of gamma is at 4 degrees Celsius. Especially for the water, 1000 times 9.81. So the answer is 9810 Newton per meter cube. And gamma of air is 1.32 times 9.81 to 12.07 Newton per meter cube. So about the specific gravity also known as the relative gravity. Okay, is the same meaning. Designed by the symbol of GSG, and then specific gravity is defined as the ratio of the density of the substance or fluid onto the density of water. So the formula is Sg fluid is equal fluid density divided by water density. For example, like if there is no unit, dimensionless. If we want to calculate the water H2O, specific gravity H2O density divided by H2O gravity density is equal to 1. But the mercury density divided by water density, so the answer is 30.546. So if you suspect gravity more than 1, that means that fluid or substance is denser than the water, while if specific gravity fluid is less than 1, the fluid is less denser than water. So another important about the parameter is viscosity. Viscosity is familiar in describing the fluid mechanics because viscosity is the measure of frictional resistance of the fluid to a flow. We describe the fluidity of the fluid, and there are two types of viscosity. One is dynamic and the secondly is kinematic viscosity. The term of viscosity always refer to the dynamic viscosity. Okay. The formula is here, dynamic viscosity, the symbol is Greek symbol mu. Symbol of dynamic viscosity. Mu is equal density, tau divided by du over dy. So mu is viscosity of fluid, tau is the shear stress, du over dy is the shear rate of strain or velocity gradient. So the SI unit for dynamic viscosity is Newton second per meter square or kilogram per meter second, or other in points where 0.1 Newton second per meter square. Kinematic viscosity is designed by the Greek symbol nu. The kinematic viscosity is defined as the ratio of dynamic viscosity to the density of the substance. So nu is equal to mu divided by rho. So the unit will be meters square per second. So other unit is Stokes, ST or centistoke, where 10 power 4 centistoke is equal to 1 meter square per second. So there is 7 exercise which is given to you. So hopefully I want all of you, each one of you must to write out and submit it on Monday. Okay, on Monday morning before 11 and submit it to the author. I forward back to you to upload all these 7 exercise. It's compulsory to all of you. Okay, now we go to the next slide. It's about the compressibility and bulk modulus. In thermodynamic and fluid mechanics, compressibility is a measure of the relative volume change of a fluid as a response to a pressure change. Bulk modulus is inverse of the compressibility but can be used to characterize the compressibility of fluid. It is defined as the symbol K is equal negative dP divided by d rho over rho. So where dP is the differential change in pressure need to create the differential change in volume and also over volume. But dV over V is a dimensionless. Therefore, the unit of bulk modulus is still in pressure unit Newton per meter square or Pascal. Bulk modulus is about the another parameter. Large value of the bulk modulus indicate that the fluid is relatively incompressible. That is, it take a large pressure change to create a small change in volume. For example, at the atmospheric pressure and temperature of 288 Kelvin is we required a pressure of 21.5 meter megapascal press a unit volume of water at 1%. This is representative of the compressibility of liquid. Since such large pressure are required to effect the change in volume, we conclude that the liquid are be considered as the incompressible, a most practical engineering application. Okay. Jadi dalam yang melibatkan kerja-kerja application engineering banyak melibatkan kes yang berkaitan dengan incompressible problem yang melibatkan the large pressure. So this is the vapor pressure. The vapor pressure of the liquid is defined as the pressure exerted by the molecule that accepts from the liquid to form a separate vapor phase above the liquid surface. If a container is closed with a small air space left above the surface, and this space is evacuated to form a vacuum, the pressure will develop in the space as a result of the vapor that is formed by the escaping molecule. Vapor pressure when an equilibrium condition is reached so that the number of molecules leaving the surface is equal to the number entering. The vapor is said to be saturated and the vapor pressure that the vapor exerted on liquid surface system is the vapor pressure. So the vapor pressure is influenced by the temperature and the nature of liquids. Some liquid consists of molecules that have a very weak attractive force between them. So these liquids evaporate easily. Your volatile thus have higher vapor pressure. Another parameter is we call the surface tension, sigma S. Surface tension can be defined as the intensity of intermolecular attraction or attraction force per unit length along the free space of the fluid. The effect is caused by unbalanced cohesive force at the fluid surface, which produce a downwards resultant force which can physically seen as the skin or membranes. Surface tension is the fluid property and it is depends on the temperature and also on the types of the solid surface interface. For example, a drop of water on the glass surface will have a different coefficient from the similar amount of water on the wood surface. Unit for the unit surface tension is Newton per meter. So the value of surface tension decrease as the temperature increase. Bila suhu meningkat, maka dia punya surface tension ni akan berkurangan lah. So dia punya tu kadar secara tidak langsung. Surface tension sigma as follow. The formula is given F divided by 2B. Okay. So this figure show about the difference between fluid and surface tension. If you see fluid of the water very high, sorry, the mercury very high compared to the 0.014 water at 300 degrees Celsius in contact with air. So this is a example of surface tension. A U-shaped wire frame with a centimeter long oval side. So this is a capillary effect. So this is the formula how to calculate. So the formula is given solving to high give a capillary rise to be H is equal to sigma cos theta divided by gamma R. So sigma is the surface tension in unit of force per unit length. Theta weighting angle. Gamma is the specific weight of liquid, and R the radius of tube. H is the capillary rise. So this is the problem sample of the capillary rise of water in the tube. You can see how to use the formula regarding to the questions as is given. Okay. So this is some of the table 1.6 and 1.8 uh, with the constant value with the different types of liquid and gas. Okay. The last sample of slide is the dimension and unit. Dimension is the measure of the physical quantity, for example, like length, time, and mass. So the unit is the assignment of the number of to the dimension, for example, like millimeter, meter, kilogram, gram. So there is 7 primary dimension in this topic. Number one is a mass, symbol in m unit a kilogram, length L, m, times T, second, temperature, capital T, in Kelvin, current I, ampere, amount of light C, candle, amount of metal, and mole. So this is the in fluid, we just consider three symbol M, L, and T. All non-primary dimension can be formed by the combination to the primary dimension. For example, like velocity, the length divided by time, so L over T, and then the force, mass length per time, so ml over T square. So uh, lastly, we call it the dimensional homogeneity. What is the dimensional homogeneity? The equation can be said as the dimensionally homogeneous if the dimension of the left side of the equation is the same as those on the right side, or all additive separate terms must have the same dimension. For example, the equation of the density V of the uniformly solid body is V is equal to VO plus AT. So VO is the inertial velocity, is the direction, and T is the time interval. The internal dimension of the equation is LT power minus 1 is equal to LT minus 1 plus LT minus 1. So all terms give the same dimension, thus the equation can be considered as the dimensional homogeneous. Sekian, wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi taala wabarakatuh.